Okay, the last two pages of the mock exam are, a little boring for you probably because it's conics and we just did conics, okay? So, let's see. First, we're going to graph a hyperbola, and we just need to identify certain things about this hyperbola, such as under the x, we're going to have the a squared, and under the y, we're going to have the b squared. What does the a and b tell you? The a and b tells you the size of the rectangle at the middle of the hyperbola, whereas a is a half width and b is a half height. Another thing you can get from A and B is the focal length, and we're going to see that in a second. Okay. What else can we see? Well, we have basically the y squared term minus the x squared term. If we have a y squared term minus the x squared term, that means that our hyperbola is like a top-bottom hyperbola. It looks kind of like that as opposed to here. Okay. All right. Write down the coordinates of the vertices. Okay, since we have a top-bottom hyperbola, that means we know that the vertices are located here and here. Okay, so another thing we can see is the h and the k values. The h and the k values are here and here. Okay, so the h and the k values, the h value is next to the x, so it says x minus 3, so the h value is positive 3. And the k value, minus k is positive 3, so k is equal to negative 3. Okay, so here is our center. So let's draw that. 3, negative 3, there's our center. And then we know that our a value, our half width, is 2, and our b value, the half height, is 4. So we're going to make our rectangle half width 2, and half height is 4. So we're going to draw the rectangle based on that. Okay, there's our rectangle. And so from the rectangle, we can figure out that the vertices are, since it's a top-bottom hyperbola, remember, the vertices are here and here. So the vertices are going to be 3, 1. Vertices are 3, 1, and the other one is going to be 3, negative 7, right? All right, so that's the vertices. And then it says to find the foci coordinates. The foci coordinates are going to be a distance c away from the center. So how do we find c? C is equal to a squared plus b squared. A squared plus b squared is 16 plus 4, which is 20. So c is equal to the square root of 20. So square root of 20 4.47. So c is equal to 4.47. And notice that the vertices are top-bottom. So that means that the foci are also top-bottom. So the foci would be located around here and around here. Okay? And the coordinates would be slightly above the vertex, but it would basically be c distance away from the center. And remember, our center is 3, negative 3, right? So the center is 3, negative 3. So that means that one of the foci is going to be 3, negative 3 plus 4.47. And the other one is going to be 3, negative 3 minus 4.47. Okay? Because one of them is going to be above and the other one's going to be below the center. And so I can add this up. I go 1.47 here, and then here I get 3, negative 7.47. Okay? So those are the coordinates of the foci, and I've marked them here. And then last of all, we need to make the asymptotes. and the asymptotes you draw with dotted lines, and the slope of the asymptote is 4/2, so that would be about like that. Like that. And do you see how the rectangle helps you draw the asymptotes? Okay. These are terrible. I mean, I'll try to give you a ruler during the exam. Okay. And then now we just draw our hyperbola, and we're going to draw the hyperbola through the vertex, and then it follows the asymptote as it goes out. So it goes like that. Do you see how the foci are inside the hyperbola? So I think that's it, right? Okay. Let's move on to the last problem, which is to do the same thing with an ellipse. Okay, the ellipse equation looks an awful lot like the hyperbola equation, except for instead of a minus in the middle, you have a plus. Okay. Where is the center? The center of this one would be h equals +3 and k equals -1. So it would be 3, -1 is the center. So let's draw the center. 3, -1 is right there. Okay. What about the a value and the b value? The a value is a squared is 9, so the a value is 3. And the b value, b squared is 4, so the b value is 4. Okay. Find the foci coordinates and show all the work. Okay, remember that for an ellipse, the equation for the foci, and you could write this here, is equal to a squared plus equals b squared plus c squared. Write that on your formula sheet. And by the way, for the formula sheet on the hyperbola, you're going to want to write that the equation for c is this one here, which is a little bit different, right? Okay, and so a squared equals b squared plus c squared. So we know that it is 3 squared, which is 9, equals 4 plus c squared. So basically, 9 minus 4 is 5. So c is equal to square root of 5. Let's see what that is. 2.24. Okay. So c equals 2.24. We know that this particular ellipse is a wide ellipse because the a value is bigger than the b value. If it's a wide ellipse, that means that the foci are along the x-axis, 2.24 away from the center. So it would be like here and here. Those would be the foci. And the a value is 3 and the b value is 4. So that means that the edges of the ellipse are going to be separated by 3 and separated by 2. I'm sorry, I said b value is 4, but the b squared value is 4. The b value is actually 2. So, okay, and the red points are the foci. Okay, and that's it.